It was done in Barcelona in the Institut de Robòtica i Informàtica Industrial, which is a mixed research center between the UPC, the Polytechnic University of Catalunya, and the Spanish Council of Scientific Research. And well, it's about adaptive assistive robotics. So I will start trying to motivate why we need assistance. I'm sorry that that's cut. I did them 6-9, 16-9, and at least for 3, but fine. So why do we need assistance? Mainly because people is getting old around the world. This is a problem that's, I think, it's almost every country. There's aging population, and this means that there's a lack of healthcare professionals. That's quite obvious in countries like Japan, where they try to import many nurses and healthcare professionals, but there's not enough people taking these jobs to kind of cover all the demands. That's that. And apart from that, there's also like the personal issues that the assistants are, which is that the loss of independence of the people that need this assistance, which usually generates some impact in the psychological well-being, because needing someone to feed you, someone to clean you, and all this kind of stuff, it's not good for yourself. So these people tend to feel powerless, useless, and then obviously this has a bad impact on them. So in that case, we think that robots can help by providing assistance and, what's more important, by empowering these users. So many people see that as, oh, you're taking the healthcare jobs. First of all, there's not enough healthcare for all the need there is. Secondly, no one is, or not much people is thinking about that this is helping the users to feel empowered, to feel more independent, and to kind of live a better life. So when we're talking about assistive robotics, there are mainly two kinds of assistive robotics. One is the social assistive robotics, which are mainly social robots that can try to encourage the person to do some things, to take the medicines, to exercise or guide some exercise section, things like that. And then there's the physical assistive robots, which is the ones we will talk about, which kind of have some physical contact with the person. So that's do tasks such as feeding, dressing, cleaning, shaving, and this kind of stuff. And I will focus on these ones. However, we cannot really assist everyone in the same way, because like when people assist someone, they adapt to the person needs. So for instance, these are some videos from nurse training, and as you can see, there's many differences in how the professionals assist the different users based on the position, the capabilities, the abilities, and how does the person behaves. So if we assist a person in a different way depending on the person and depending on their needs, this means that the robot should also adapt to the person that they're assisting. So I will focus mainly in assistive tasks, and that's because like we should understand and explain what the robot is doing, because obviously it's not pleasant to have like a big iron thing going to your face when it's feeding you. So the robot should behave in a way that it's clearly understandable for the user, or should kind of explain itself what it's doing. Mainly because usually the kind of users we're targeting are not aware of what's happening, are not technologically capable. So the robot should behave kind of like a human would do, like should be really legible. And then the user should be able to kind of program or adapt this behavior without having these technical skills, which means that maybe the caregiver can just make this adaptation, or the user itself can express its needs or preferences so that the robot adapts to that. And this results in an empowerment of the users. As I said, we don't want to substitute the caregivers, we just want to have the users be able to do these things by themselves. And because like the state of the art is quite bad yet, so I think we can do better than this. So I will focus in three tasks, which are feeding, shoe fitting, and jacket dressing, and then I will go around the adaptation that's in it. That I will first play this video. Well, first of all, this assistive feeding is just a demo example of the different tasks, and mainly there's many challenges here, mainly because we have a person in front, so we can basically kill the person if we're not careful. So there's this thing that we should be really precise on putting the spoon in the mouth. So there's many detection, computer vision problems here. Also robot control, how to move to get close to the person and to insert the spoon in a precise manner. How to do the task without forcing too much the user, but also sometimes we need to make some force. That was us. I mean, I was used to it, but it's really hard to, like everyone's telling me, why are you doing such a face? It's like, well, have you ever been recorded while having a robot put something in your mouth? So yeah, and then we're assuming that we are using a spoon, no sharp tools to not kill anyone, and we're assuming the person to be in a known position. Then there is shoe fitting. For the shoe fitting, there's many problems. Mainly, most of the shoes have laces. That's a no-go for robots for now. So in this case, we just assume this kind of croc-like shoes. And then we have also jacket dressing, which is kind of the most complicated one because we need two arms to do that. Because the garments are flexible, so it's hard to detect them, it's hard to manipulate them. And also we need some precision to fit the sleeves when we cannot really see the sleeves. So in this case we will need some user collaboration. And also depending on the user capabilities, if we fit one arm, then it may force the other arm, so there's some kind of relation between the arms. And in this case we're also assuming that the person is in a certain position and can move a bit. But in this case there are many strategies, like we can just go one arm and then the other, we can do both arms together, or we can play with different configurations. And we're done. We can actually dress someone with this. But of course we're not even considering dressing a shirt for now, because obviously that's way more complicated and way more dangerous. So how can we adapt the robot behavior? Ideally, we should do that in an automatic manner. We should get like the information from the user and just adapt. It should be done for and by non-expert users, because we cannot assume really that the someone with problems, some older adult will have C++ knowledge to program the robot. And it should be long-term, because what happens is that the person is usually adapting also to a robot. So maybe we'll have the robot that adapts to the person, and then the person will get used to the robot, so it will start to adapt to how the robot works, and then the robot may need to readapt to that. So it should be a bit long-term, therefore it should be an iterative process. So how we see it is something like this. So we will have a robot, we'll have a user, and there will be some interaction involved, because the user should be able to know and see what's the robot doing. And then we'll have the assistive execution that should adapt to the user behavior. And for that we'll have some user model and some preferences. So I will now talk a bit about the preferences, but the idea is that we'll get some user preferences and then use them to adapt the robot behavior. And to adapt the robot behavior, we define this framework which we call FUTE, which has kind of 3 steps, in which first we have some factory setting, which like you buy the robot knows how to do the task, and it's pre-programmed to do a task in a generic way. And then we have the user tailoring phase, that when the robot arrives at home, then the caregiver or the user adapts and kind of reteaches the behavior of the robot or sets the preferences, and then the execution tune in which the robot performs the assistive task with the relearned preferences or behavior, and this is kind of an iterative process that can be done and repeated over time. And this is an example of this. There was just an easy example of how this personalization phase would be. So now the robot can just feed someone, do the movement in a normal way, and then the caregiver here just holds the robot in the position where it's comfortable for the person. So maybe this person can move a bit, so it doesn't want the robot to put the spoon in the mouth. So then, like, the caregiver can just hold the robot, say, hey, just wait here because the person will go and get the food. And in this case, then it just repeats that with the new trajectory.